Well, hello, folks. Today is brought to you by this fancy little top that I bought off of Wish. Came from China. Virus free. It's not brought to you by anything. I'm joking. Nobody pays me to do this other than Waterbury. Basically, your parents pay me. All right. We are talking about lesson number 20 today. This should take you 40 to 45 minutes. It took me about 15 minutes, so I understand if it takes you guys a while because, you know, I'm the teacher. We're talking about basics of circles. A circle is a set of all points in a plane that is a given distance. Equidistant from a given point in the plane. A circle consists of an infinite number of points and sides. Okay. The tangent to a circle at a given point is a straight line. Straight line is a line that just touches the circle at one point. If it's not straight, it's not a line. These are two tangent. Excuse me. My allergies are acting up, so my voice is a little cracky. The radius of a circle is a segment from the center to the edge. Basically, the radius is the distance from any point on the circle to the center. The diameter is a special chord that leads into what I'm about to tell you guys later that contains the center, and that's it. A chord is a segment whose endpoints are points on a circle. On the circle. All right, so there's a special relationship between the tangent of a circle and the radius of a circle. I am going to show you my GeoGebra and show you what it's talking about. I hope you can see this. This right here, the GeoGebra file, shows circle A. So circle A. And it says turn on the tangent line. Turn on the tangent line. Actually, the tangent line's already been turned on when you load it. Who cares? Turn on the tangent line. You should see a line appear that seems to only intersect circle A at point B. You can move the point around. See, you can move the point around. Notice what happens to, I'm trying not to worry about the diameter of the circle, but notice what happens to this line, the tangent. It's always touching at point B. Okay? Now, turn on radius AB. Radius, segment A to B. Oh, look, there you go. Now, what can you tell me about these two lines that appear? Like, what does this look like? This segment to this line, what do they appear to be? And what does it always appear to be? If you turn on angle A, which is the next one, you'll get the answer for both B and C. Angle A is a 90-degree angle. Always. The tangent, by definition, is perpendicular to the circle, but it's perpendicular to the radius. The reason I say perpendicular to the circle is because the radius makes a perpendicular line to the tangent. Back to this. Flip it over. Oh, that's the front. Okay. So question number 2. There we go. Watch the video. Okay. About how to construct a perpendicular bisector. I want you to watch that video. That's actually kind of important. Open up this GeoGebra file to answer the questions below. I have the GeoGebra file opened. As defined above, chord, when it says above, it means way back here. Chord. Chords are line segments with endpoints on the circle. See? On the circle, not on a circle, as before. You can move points E, G, and F around the circle to change E, G, F, and D. You can move all those points. I don't know why it doesn't include D. But if I were to move these points, If I move F over here and over here, it's always on the circle, right? Can you have intersecting chords? Why not? Who cares? Is a diameter a chord? That's this question right here. As I said before, a diameter is a special chord. A diameter is a special chord that passes through the center. If I go back to the GeoGebra file, D to E, if it passes through C perfectly, I now have a diameter. Okay? It says, move the points that define the chords around. Does your observation hold true? Oh, turn on the perpendicular bisectors, okay? So if you don't see the perpendicular bisectors, you click right here. It opens up the tray. Oh, look, perpendicular bisectors. 1 and 2. I'm going to close that back up. Now, what can you tell me about where the perpendicular bisectors cross? Hint, hint, it's always at C. You can always find the center with a perpendicular bisector. If I go and I take this paper here and I do a perpendicular bisector, guess what? Perpendicular bisector, I know this is a perpendicular bisector because it's passing through the center. The converse is also true. If a line segment, or if a line passes through the center of the circle and these are both equal, if this is a bisector, this must be perpendicular. Or if this line segment is perpendicular to a chord, these must both be equal. Or if this is a perpendicular bisector, this must pass through the center. And it doesn't matter if you're looking at the computer again, it doesn't matter where this is. Take a look. I can make this circle huge. Notice how it's still passing through the center, even if I flip it to the other side. It still passes through center. The intersection is always the center of the circle with perpendicular bisectors of any chords. All right, flipping on to the next question. Enough of the computer. Hope you guys can see that. A lot of times video has troubles recording an LCD screen or whatever kind of screen I have. A farmer standing at point X. Now, I don't like the way this diagram shows. This diagram should be more like this. But it's hard for you to understand. Oh, I'm sorry, not like that. That side is fine. This side should be like this. I don't know. It's difficult to explain. It doesn't look like it's possibly correct. But just remember, the longest side of any right triangle is the hypotenuse. Okay? And if this is a right angle, that makes this the hypotenuse. A farmer standing at point X. Point X is 42 feet away from the center of a cylindrical storage silo and 36 feet away from point Y. Find the radius of the silo to the nearest tenth, given that XY is tangent to circle O at Y. So if this is tangent, he's 36 feet away. He's 42 feet from here. Since XY is tangent at O, what can be concluded about angle XYO? If this is tangent and this is the radius, what must this angle be? Must be 90. Cite your reasoning from this lesson. The reasoning is definition of a tangent line is always perpendicular to the radius. And think about it. If it wasn't, let me show you the computer again. If a tangent line wasn't perpendicular to the radius, it would cross at more than one point. I don't know if you can see. There you go. It would cross at more than one point. It has to be by logic. It has to be. Back to this. So, given your answer to A, write the equation that relates to this. Well, we know this is 42. Do we know how big the radius is? No. But we do know that this is the radius, right? So we can actually make an equation that looks like this. The hypotenuse, A squared plus B squared is equal to C squared. The hypotenuse, C squared, is 42 plus the radius. I know that. How do I know that? Because it's 42 plus the radius. Let me turn the camera so it doesn't look like I'm twisting. There we go. Now, I always have to twist my paper. I'm weird. Get over it. This quantity squared is equal to, this is my c squared, a squared, or a squared, whichever, r squared plus 36 squared. Yes, I'm going to use my calculator for this. Since this is a binomial being squared, that makes it very easy. 42 squared is 1764. 1764 is equal to, FOIL it. First times first, first times last, last times first, last times last. 42r plus 42r is 84r plus r squared is equal to r squared plus 36 squared. 36 squared is equal to 1296 plus r squared. Oh, look, I have a plus r squared on both sides. So that just kind of goes away if I subtract both r squareds. Now I have a very simple problem. R, 1296, 1764, 1764 minus 1296 is equal to 468. Plus 84r is equal to 0. This isn't working out. Hold on. Because if you think ahead, if I subtract this, then I'm going to end up with a negative and then divide by 84 and it ends up with a decimal. So let me see what I did wrong. 42 squared, 42 plus 42 plus r squared, a squared plus b squared is equal to c squared. C squared is 42 plus r. Shouldn't be negative, which is the problem. Hold on, bear with me. My apologies. I don't see what I'm doing wrong. C is 42 plus r. Then we have r. And we have 36. (36 squared, a squared plus b squared equals c squared. Oh, here's where I went wrong. Read the problem, genius. 42 feet from the center. Not 42 feet from the edge. 36 feet from the edge. 42 feet from center. So it's not 42 plus r squared. Wrong, 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 wrong. Bear with me. My bad. Helps to read the problem, folks. So we have 42 squared is equal to, so that's c squared, r squared plus 36 squared. That looks way better. So 42 squared, 1764 is equal to 36 squared is 1296 plus r squared. I'm going to take 1764 minus 1296, and that's 468 is equal to r squared. Take the square root of 468, and that's 21.63330.765, but it says round to the nearest tenth. So we have 21.6. That cannot be right. 42, 36. No, I guess it is right. Okay. 21.6. What's the measurement? Feet. Okay. Given OT, oh, here's a little diagram down here. Given OT is equal to 5, XT is equal to 12, XT is equal to 12, that makes this a right angle, 5, 12. Automatically, this is 13 right here. Don't think that this is 13. The radius is this. Is XY tangent to circle O at T? Now, where is it? XT is 12. OX is 13. Oh, what am I thinking? Wow, I way overthought that. It actually tells us that OX is equal to 13. I saw 5, 12, 13, which is a Pythagorean triple if you think back. And since 5 squared plus 12 squared is 13 squared, 5 squared is 25, 12 squared is 144, 25 and 144 is 169, which happens to be the perfect square of 13, 5, 12, 13. That makes this a perfect right triangle. And like I said before, where's the paper? Up here. The converse of these, if this is a right angle, even if it's a tangent, then this is a radius. No, that's not the one I said that for. Up here. There we go. If we have a tangent right here at B, it must be 90 degrees. If it is 90 degrees, it must be tangent. The converse of that, of the tangent, makes it true. I think that's it. Hey, short video. Just had a mental brain fart right here because I didn't read the stupid problem. All right, guys. Have fun. Stay safe.